Welcome to today's lesson on representing linear non-proportional situations with tables and equations in the form of y equals mx plus b. We have two TEKs for today. It's 8.5b and 8.4c. Our essential question is, how can you use tables, graphs, and equations to represent linear non-proportional situations? So we have a few vocabulary words. The first one is ordered pair. So the definition for that is a pair of points in a fixed order that includes the x-coordinate and the y-coordinate. So ordered pairs are just written as x comma y. Another word for it is coordinate. Then we have proportional relationships. So this is relationships between two variables where their ratios are equivalent. So remember, k is equal to y over x, the ratio of y over x. And the equation for that, when we do write an equation, is y is equal to kx. One variable is always a constant value times the other, right? So we have our constant of proportionality, which is our k, times our x value. Then we have non-proportional relationships. That's where relationships between two variables where the ratios are not constant equivalent. So we can't use that k is equal to y over x. We actually use a different equation, which is m is equal to y2 minus y1 over x2 minus x1. And non-proportional relationships have a y-intercept that is not equal to 0. So whereas the proportional relationship goes through the origin, our non-proportional relationship is written as y equals mx plus b, b being this y-intercept, or where the line crosses the y-axis, and then our m being our slope, which is similar to that constant of proportionality. So both the slope and the constant of proportionality are a type of rate of change. And so a rate of change is a rate that describes how one quantity changes in relation to another quantity. So proportional and non-proportional relationships are linear, or can be linear, because they can be a straight line, right? At least the proportional and non-proportional relationships we've been talking about. So a linear equation is an equation between two variables that is a straight line when plotted on a graph. So then we have slope-intercept form. So slope-intercept form is the official name for this y equals mx plus b equation for non-proportional relationships. It's the equation of a straight line where m is the slope of the line and b is the y-intercept. And lastly, the y-intercept, again, is the point where the graph intersects the y-axis. So here we have this table 0, 3, 1, 5, 2, 7, 3, 9. If we wanted to figure out whether this is a proportional or non-proportional, we can try using this equation, k is equal to y over x, right? So we would do 3 divided by 0, 5 divided by 1, 7 divided by 2, 9 divided by 3, just to see if they're all the same. So 3 divided by 0 is undefined. We can't do that, but we have 5 divided by 1 is 5, 7 divided by 2 is 3.5, and 9 divided by 3 is 3. So we know that this is a non-proportional relationship. And so to find the rate of change, we would have to use this m is equal to y2 minus y1 over x2 minus x1. Okay, we just have to review some vocabulary words. So these are operational keywords, so keywords for math operations. We have the word quotient. Remember, the quotient of two numbers is a result of dividing two numbers, right? So that's division. So 15 divided by 5 is 3. 3 is called the quotient. Then for products, the product of two or more numbers is a result of multiplying these numbers. So when we multiply, our answer is called the product. Okay, then we of course have sum. So the difference of two numbers is a result of adding these two numbers. It should be the sum of two numbers, the result of adding the two numbers. And lastly, for difference, the difference of two numbers is a result of subtracting the two numbers. So the answer when you subtract is called the difference. Okay, so our activity, we're going to complete the table given what the x values are. So we see that x is equal to -2, 0, 1, 2, 4. Okay, so our first equation is y equals x. So if y is equal to x, we know that y is going to be, when x is -2, y is also going to be -2. Then we know that when x is 0, y is also going to be 0. When x is 1, y is also going to be 1. When x is 2, y is going to be 2. When x is 4, y is going to be 4. Next, we have a different equation. We have this y is equal to 2 times x, right? So we're multiplying 2 times each of these x values here. So 2 times -2 is -4. We have 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 4 is 8. Now we are doing y is equal to 1/2 x. So we have 1/2 times -2. Remember that multiplying by 1/2 is the same thing as dividing by 2. So -2 times 1/2, or -2 divided by +2, is -1. We have 0 times 1/2 is going to be 0. 1 times 1/2 is going to be 1/2. If I were to write that as a decimal, that would be 0.5. Then we have 2 times 1/2, which is going to be 1. And lastly, we have 4 times 1/2. 4 divided by 2 is 2. Okay, so next, or last, I guess I should say, we have y is equal to m times x. So we don't know what our m is, right? But we do know that our x is -2. So I'm just going to write -2m, or -2 times m. Okay, next we have 0 times m, which we know is going to be equal to 0, right? Because every number times 0 is 0. Then we have m times x. So x being 1, so we have 1m. Then we have 2m, because we have the 2 times the m. And lastly, the 4 times the m. Okay, so we already did that for that first table. The second table, we have the same x values, -2, -1, 0, 1, 2. And again, we have that same equation, y is equal to x. So this first column is super easy to complete because we're just writing the same x values for our y values, because x and y are the same. So it's the second one. We have y is equal to 3 over 4x. Okay, so if we don't know how to do 3 over 4 times -2, as a reminder, you can always turn whole numbers into fractions by putting it over 1. So I'll do this first one as an example, but then I'll show us how to do it on Desmos. 3 times -2 is -6. 4 times 1 is 4. Then if we were to divide -6 divided by +4, that would be equal to -1.5. Okay, another way to do this is through Desmos. So I can type 3 divided by 4 times, and then each of the numbers, like -2, which was the -1.5. Or what I can do is type in that equation. So we have the y is equal to 3 over 4 x, and then from here I can make a table for this equation. So to make a table, I'm going to go to the settings, I'm going to click table, and of course I have to look at the values, right? So in this case, we actually don't have to change the x values on the side right here because it already is what the numbers that we need, right? We have -2 is the -1.5. Then we have, when x is -1, we have -0.75. When x is 0, we have 0. When x is 1, we have 0.75. When x is 2, we have 1.5. So I'm going to go ahead and complete this column of the table. Okay, so now we're going into our we do. So we have to examine the linear relationship. The equation is given, y is equal to 2x plus 3, and we have to create a table to represent the relationship. Okay, so we have our x values of 0, 1, 2, 3. So then in the middle, this is a 3-column chart. It has the equation, right? So in this parentheses, we see that we have 2 times x. So if our x is 0, I'm going to do 2 times 0 plus the 3 to get my y value, right? So 2 times 0 is 0. 0 plus 3 is 3. Next, when x is 1, I'm going to put in the 1 in the parentheses, so 2 times 1. And then we're going to add 3. 2 plus 3 is 5. Then next, when x is 2, we have 2 times 2. 2 times 2 is 4. 4 plus 3 is 7. And lastly, when x is 3, we're multiplying 2 times 3, which is 6. 6 plus 3, which is 9. So this is a vertical table, right? If we took out that middle section of the 2x plus 3, we have our x values on the left side, our y values on the right side. Now we're going to transfer the numbers into our horizontal table. So when x is 0, y is going to be 3. When x is 1, y is 5. When x is 2, y is 7. When x is 3, y is 9. So if we actually look back to this table from our vocabulary, this is the same table, right? Or the numbers are the same, except this is our vertical table. And of course, this is our horizontal table. And just like I proved earlier, this is non-proportional because when we try to divide y divided by x, the numbers were not the same. Okay, so then we have our next we do. It says Mr. Fixit charges $30 for a service call and $50 per hour for labor. Which table is the correct representation of this scenario? So we actually have to write an equation for this problem. We have y is equal to, we have 30, and if it has the word and, we know that means plus, right? We're combining. Then it says $50 per hour. Per means that we're multiplying, right? So if we're multiplying, we know that we're going to be multiplying by another number that represents the number of hours. So that's going to be represented by x in my equation. So we have y is equal to 30 plus 50x. So now I'm going to make a vertical table. So x on the left side, y on the right side, and I'm going to use Desmos to do this. So of course I can always plug in. You can see that for all of the tables and the answer choices, they all utilize 0, 3, 6, 9, and 12, right? So I know that my table that I make is also going to have 0, 3, 6, 9, and 12. So we can do what we did earlier in our activity where we plugged in, or for our first we do, where we plugged in the x value into this equation, right? So I would have done 30 plus 50 times 0, 30 plus 50 times 3, 30 plus 50 times 6, 30 plus 50 times 9, and 30 plus 50 times 12. But I'm also going to show us how to do that on Desmos. So I'm going to clear all of the other equations that we had written. And now I'm going to type in our new equation, which is y is equal to, we have 30 plus 50x. And then again, I'm going to make an equation, or I'm going to make a table for this equation. And to do that, I'm going to go to settings, press the table. And of course, now I have to change these x values, right? Because we don't have -2. So I'm going to delete that, write 0 or type 0. Then delete the -1 and do 3. Then delete the 0, put 6. And then I'm going to put 9. And lastly, I'm going to put 12. Okay, so you can see that I now have my completed table, right? So when x is 0, y is 30. When x is 3, y is 180. When x is 6, y is 330. When x is 9, y is 480. When x is 12, y is 630. So I'm going to go ahead and write that down. So we had 30, 180, 330, 480, and 630. So now I'm going to choose which horizontal table matches this vertical table, right? So over here we have when x is 0, y is 50. That is obviously not correct. So A is not correct. B says when x is 0, y is 30, which yes, that's correct. When x is 3, y is 180, that's also correct. When x is 6, y is 330, that's also correct. When x is 9, y is 490. This 490 is not correct because it actually needed to be 480. But I can see that our last answer choice, C, has the 480. And then when x is 12, y is 630. So B was the correct answer. And then on to our last we do. So now we're given a table and we actually have to find the y-intercept, the unit rate, as well as our equation. So for this problem, it says the table below shows a relationship between x and y values. We have to, again, find the unit rate, y-intercept, and equation. So to remind ourselves, we have y is equal to mx plus b is the form of the equation that we are using for today, since we're focusing on non-proportional relationships. The unit rate is going to be our m. That means the y-intercept is our b. Okay, this will be important for when we find the answer on Desmos, or when we check our answer on Desmos. But we're going to start off by doing the work by hand. So if you remember earlier on the slope formula when we were talking about the vocabulary, m is equal to y2 minus y1 over x2 minus x1. Okay, so if we're going to use that equation, then of course we're going to have to go ahead and label some numbers in our table, x1, y1, x2, y2. Okay, so I like to use the first 2 points that I see that are positive. So we have 1 right here, I'm going to label that x1 because it's our first x coordinate. The 18 is going to be y1 because it's our first y coordinate. Then we have 2 is going to be x2. It's our second x coordinate. 21 is going to be y2. It's our second y coordinate. From here, I'm going to plug in the numbers. So y2 is 21. Y1 is 18. So now I have 21 minus 18. X2 is 2. X1 is 1. So I have 2 minus 1. So now I'm going to go ahead and do the math. 21 minus 18 is 3. Then we have 2 minus 1 is 1. And lastly, we have 2 divided by 1, which is 3. So our unit rate is 3. So I'm going to start writing our equation because we have our unit rate, so I can at least write the y is equal to 3x part, right? But we don't know what b is, so I'm going to keep that blank. But down here, I'm going to write y is equal to 3x plus b because we do have to solve for b. And what I'm going to do is I'm going to choose our first point that we used. I'm going to choose the y value and then the x value and plug it into our equation. So our y value is 18, so we have 18 is equal to 3 times our x value, which was 1, plus b. And then from here, I'm going to go ahead and do 3 times 1, which is 3, plus b. So now we have a one-step equation, and I want to move the 3 to the other side. I want to just isolate the b. I want to get the b alone. So what I'm going to do is I'm going to subtract 3 on both sides. So 3 minus 3 is 0. That's a 0 pair. And then we have 18 minus 3, which is 15. So then we have b is equal to 15. So of course, I'm going to write that in here. Our y-intercept is 15. And lastly, I'm going to complete our equation. So we have y is equal to 3x plus 15. Okay, so now I'm going to show us on Desmos how we're going to get the same answer. So to do that, I'm going to go ahead and clear the whole thing. This time we're given a table, right? So we have to make a table on Desmos. And so I'm going to go to plus, I'm going to go to table. So then I'm going to type in 1, 18, 2, 21. So these are the values in the horizontal table that was given to us. 3, 24, and lastly 4, 27. And I'm going to type in y equals mx plus b, but because we're trying to solve for m and b, I can't use the equal to sign. I need to use the tilde. And because up here, you can see that it doesn't just say y in our table. It says y1. I also need to indicate y1. So I'm going to use y1 tilde. Then we have mx1 plus b. And you can see that our m, or our unit rate, is 3. Our b, or our y-intercept, is 15. So the rest of the PowerPoint is going to be the independent practice. Thank you so much for paying attention and following along in today's lesson.